In this video, I'm gonna go over how to set up an integral for a simple volume calculation. We have a pyramid here, which has a height of 5 meters. It's kind of tipped on its side in this drawing. So this is the base, and this is the top of it, the tip. So from 0 to 5, that's the height. And it also has a square base, where the side is 5 and 5 meters. Okay, this is kind of the formula that I'm going to be relying on, or a setup, or whatever you want to call it. So the volume equals integral of the cross-sectional area, this one, times, and the dx, which will stand for the width of our cross-section, and we're going to have the limits from a to b. Okay, I'm going to go ahead and let's see how all this applies for our situation here. So I'm going to write it down here. V equals. Now I'm going to put the integral sign. Let's take a look at our area of cross section, which is going to be our AX. So somewhere along this pyramid, I'm going to take a cross section. The base is a square, so we're going to take a cross section parallel to this base, so therefore that's going to be also a square, and it's going to be at the height of x from the base, or from the origin O, from the top, and the sides of it is going to be also x and the top x. So the area of a square is x times x is going to be x squared. This is our function of the area in x, and therefore we're going to take it and plug it in into our integral. So ax is going to be, make a parenthesis here, x to the square. Okay, our dx, we're going to put that in unchanged. Now let's take a look at our limits, a and b. What does that mean? That means our function is ax, which will be, the a is kind of like y equals ax, so our y function. Now the limits will dictate how our x will move, and we want it to move from 0 all the way till we get to 0.5. That's our height. So that's what's gonna be our limits. 0 our lower limit, and 5 will be our upper limit. So I'm going to put here 0 and a 5 up here. Now we're going to go ahead, we're going to solve our integral, and we're going to find our value for the volume. So this is equal to x squared. The integral for that would be x to the cube over 3, and we still have to plug in 0 to 5, which is equal to, let's see, we're going to plug in the 5 in the place of the x. So 5 over 3, but the 5 is on the cube, minus, now it's the 0's turn. We're going to take the 0, plug it into the x. So it's going to be 0 on the cube, divided by 3. This whole part is gone, it's 0. So all we have to worry about this, which we can find with a calculator. And there it is. We found our volume, 41.67 meters cubed. And there you go. That's our value for the volume of the pyramid. Square base, 5, 5, and the height of 5.